All right, and welcome to today's lesson. In this first tutorial, we will use the law of sines to solve any triangles. We are in section 7.2 in our textbooks. Last tutorial, we were using exclusively right triangles. The law of sines is something that we can use to solve any triangles, obtuse triangles and acute triangles. So it's set up like this. If we're given little a, little b, little c, they're sides of any triangle, and they are of course opposite their correct angles, angle A, angle B, and angle C respectively, then we can create three ratios. The ratio that compares the side little a to the sine of its angle will always be equal to the ratio that compares little b to the sine of its angle, and those will both be equal to this ratio that compares little c to the sine of its angle. And that's the law of sines. The law of sines is a set of three ratios that compares the side to the sine of its angle. What we're going to do is we're going to find two of these ratios, set them equal to each other, and solve that proportion. So the law of sines can only really be used when we have both numbers in one of these ratios, meaning we have side B and its angle. If we don't have that, then we're going to need something else in this chapter called the law of cosines. One more thing before we start our first problem. Right now we know that angles are measured in degrees, but we can actually get a little bit more accurate than just degrees. Let's say we have an angle that measures 32 degrees, 45 minutes, 17 seconds. These are probably new symbols to many of you. This is just a more accurate way, a closer approximation of this angle. Instead of stopping at degrees, every single degree is actually broken up into 60 tinier units called minutes, and this is your minutes symbol. And actually, as tiny as minutes are, remember there are 60 tiny minutes in each degree. As tiny as those are, each minute can actually be divided into 60 tinier units called seconds, and that's the symbol for seconds. So we can get pretty darn exact when we're measuring our angles if we use degrees, minutes, and seconds, or DMS mode. Now where you find this in the calculator is you have to press the second and then go to angle, and you will find these symbols. You will find your degree symbol, you will find your minute symbol. You actually won't find your second symbol, the seconds symbol, because the second symbol is actually one of your main buttons on the calculator. If you pull up your calculator, I believe it's above the plus sign. Yes, here it is. It's in my calculator, it's green. It's the green symbol above the plus sign. That's how you can get your seconds symbol. So that's pushing alpha and then the plus. So the seconds symbol is alpha and then the plus. So degrees, minutes, and seconds is what we're going to be using for our first example, just to practice that in the calculator. So here's our first triangle. I've given you two of the angles, and let's go ahead and label those. Angle C is 29 degrees, 10 minutes. So this is 29 degrees, 10 minutes. Angle B is 62 degrees, 20 minutes. So this is 62 degrees, 20 minutes. And side A is 11.5. Since none of my sides are labeled, I know that side A is going to be opposite angle A, and that's right here, so that's 11.5. And we are going to solve this triangle, and that means that we need to find the three missing measures. I know that I'm missing side B, and that's opposite angle B, so I'll put a little B here. I know I'm missing side C, so I'll put a little C opposite angle C, and I'm obviously missing angle A, but I have its corresponding side. This is not necessarily a right triangle, though I don't know if it is or not. I'm missing an angle, and maybe that angle is 90 degrees. Let's go and find that angle first. I know that in any triangle, all three angles add up to 180 degrees. So if I take 180 degrees and start subtracting the two angles that I do know, 20 degrees 10 minutes and 62 degrees 20 minutes, then I will have measure of angle A. So measure of angle A is going to be equal to that. Let's pull up our calculator. Slide it over just a little bit. Okay. So again, if you haven't already checked your calculator, in this new tutorial, make sure that you are in degree mode. I am in degree mode, so I can begin this process. 180. I don't need the degree symbol if it's just the degrees, but if it has degrees, minutes, and seconds, then I need to call up those symbols. So 29. Now I need to go to my angle. That's above the application button. Second angle gives me my degree symbol, and now I've got 10 minutes, so second angle, and that's the second one. I could push a 2 or I could push my arrow down and enter. So 29 degrees, 10 minutes. I'm also subtracting 62 degrees, so call up the degree symbol, and 20 minutes. What happened there? Okay. So 180 degrees minus 29 degrees 10 minutes minus 62 degrees 20 minutes. I'm going to press enter and I'm going to get the decimal equivalent of what this is. And since it's exactly that decimal, I can use my equal sign, 88.5. But if our problem started with degrees, minutes, and seconds, we should probably answer this in terms of degrees, minutes, and seconds. So if I go back to my calculator, instead of using my decimal, I'm going to go back to second angle and I'm going to choose option 4. Option 4 says I can convert the decimal into degrees, minutes, and seconds. So I'm going to push 4 and it's going to change my previous decimal answer into degrees, minutes, and seconds. You might have been able to do that in your head since I said that there are 60 minutes in each degree, and since 0.5 represents half of a degree, it would be 30 minutes. And 0 seconds, there weren't any seconds here. 88 degrees, 30 minutes. And I can use an equal sign because it is exactly that. Now that we've found angle A and we already have side A, we have one ratio for our law of sines. Oh, and by the way, this is not a right triangle because as this is close to 90 degrees, but it's not 90 degrees. So this we cannot use SO, CA, TOA ratios. We have to use law of sines. We are given the A ratio and we're missing part of the B ratio and part of the C ratio. So we'll go ahead and set up our proportion. I'm going to use the A ratio, side A, 11.5, divided by the sine of its angle, which in this case, because I'm going to be using the calculator, I might use 88.5 degrees just to make it easier so I don't have to keep pushing to get 88 degrees and 30 minutes, since I know that that's the same thing. That ratio, the A ratio, I'm going to choose B first, so I'm going to set it up side B, which I don't know, divided by the sine of its angle, which is 62 degrees 20 minutes. So this is our first proportion. I have the A ratio and I've set it equal to the B ratio. The only unknown is side B. So I'm going to cross multiply. I like to start with the diagonal that has the variable. So that's B times the sine of 88.5 degrees is equal to 11.5 times the sine of 60 degrees 20 minutes. And to solve for B, I'm really just needing to divide this number away. So I'll just divide both sides by sine of 88.5 degrees. Every time you're using an angle measured in degrees, please make sure you have your degree symbol. And when you plug this into the calculator, when you push this sign button, it's going to open up a parenthesis. Please be sure to close the parenthesis before you do your division. And when you do all that in your calculator, you should get 10.189 for side B. We're going to do a very similar, well, actually basically the same thing, but a different ratio. We're going to continue to use the A ratio. I do not want to use the B ratio because I only have an approximate value for B. I have the exact values for both A, big A and little a. So I'm going to continue to use that proportion, 11.5 divided by the sine of its angle. I'm going to continue to use 88.5 degrees. Saves a little bit of time. This time I'm going to set it equal to the C ratio. And the C ratio would be side C divided by the sine of its angle, which is 2910. 29 degrees, 10 minutes. There's our new proportion. I'm going to cross multiply, so C times the sine of 88.5 degrees is equal to 11.5 times the sine of 29 degrees 10 minutes. I will divide by this number, whatever that number is. The calculator will deal with that. Divide it away and I'll have C all by itself. Plugging this into your calculator, watching out for your symbols and your parentheses. When you plug that in, you should get 5.606 for side C. You can do a little bit of checking because you remember from geometry that since this is the tiniest of the three angles, the smallest of the three angles, side C is going to be the shortest side, and 5.606 is the shortest of the three side lengths. The biggest angle, the largest angle, was the 88.5 degrees, which would force side A to be the longest side, and 11.5 is the longest side. So you can kind of check yourself with your numbers. That's the end of this tutorial. That's really the only type of example I can show you for law of sines. And I'll see you in the next tutorial where we study the ambiguous case. Thanks for watching this.